Hello, and welcome to the first project management webinar. I'm Shannon Kiley with AIST, and this webinar is titled Planning for Success, Project Baseline Scope, and Budget Development and Management. As with all AIST functions, we must first go through both our policies and antitrust guidelines and anti-harassment policies. So for this webinar, all the attendee audio will be disabled. Questions to the presenters should be submitted through the Q&A feature. These will stay with the recording. And the presenters will be able to answer them after if there are too many to ask during the webinar. The host and the moderator will determine the questions that are presented at the end. This session will be recorded and will be available for demand replay on AIST's website. If you have technical difficulties, please contact training@aist.org. So photos and recordings of the presentation is strictly prohibited. You will be giving access to this information following the webinar. For the antitrust guidelines, do not discuss with others your own or competitors' pricing procedures, or anything that might affect the price, such as costs, discounts, terms of sales, profit margins. Do not make statements about your own prices or those of competitors. Do not talk about what individual companies plan to do in particular markets with particular customers. Do not disclose to others any competitively sensitive information. Do not propose or agree to any action intended to disadvantage or injure another company. Do not stay at a meeting or activity where such anti-competitive talk occurs. And I'll give you a few seconds to read the anti-harassment policy. Okay. We're having a few technical difficulties, but I wanted to introduce our moderator, Rich Dugan from AK Steel. Rich Dugan is a certified project management professional and has more than 30 years of engineering and project management experience in steel and related industries. He has had the opportunity to be heavily involved in the capital project processes for both integrated and specialty steel facilities, iron ore mining and processing, as well as coal and mining processing. He has spent more than 19 years with AK Steel in their Middletown, Ashland, and now Mansfield works, managing capital projects and assisting plant operations and maintenance with structural and mechanical related projects as needed. Rich is currently the chair of the Project and Construction Management Technology Committee, and he's a member of the Cranes Technology Committee. Rich, are you able to speak? Okay, probably not. So now I'm going to introduce the presenters. First, we have Mike Berry from Hatch. He's a licensed mechanical engineer with 9+ years experience in mechanical and piping design, as well as engineering and project management. His work has been focused in the steel and aluminum industries with project experience ranging from mining operations through finishing mill upgrades. Since 2018, Mike has been the Hatch engineering manager for the U.S. Steel Gary Works 84-inch hot strip mill API upgrade project. Next is Nick Olds from Hatch. Nick is a licensed mechanical engineer and project management professional with 13 years of experience at Hatch, working on all aspects of projects in mechanical engineering, piping engineering, and engineering management and project management. His work has spanned a number of projects in the steel industry, from iron ore mining and production through steelmaking and finishing. Since the middle of 2019, Nick has been the Hatch project manager for the NLMK Pennsylvania No. 4 reheat furnace project. And last but not least, Neil Tannyan from Hatch. Neil is a licensed materials engineer and program manager in Hatch's metal downstream practice with almost 20 years of experience. He has worked on major iron and steel projects in the USA and has also had extended assignments in Ukraine and Brazil. Neil has been an active member of the AIST Project and Construction Management Technical Committee since 2012, and he is currently the Hatch Program Manager for the U.S. Steel Gary Works 84-inch hot strip mill modernization program. Okay, take it away, Neil.
Okay. Are you seeing my screen?
Not yet.
Not yet. Let me just go to...
There we go.
There we go. Okay, we're all good. Okay, well, thanks, Shannon. Thanks for the introduction. So we'll go right into the presentation. Oops. As usual, we'll start with a safety share. I think everyone's probably a little tired of all of the COVID shares, and they're being all over the place in the news, and I'm sure a lot of companies have their own. So I was going to do a very general one, but kind of important one in this summertime on ticks. There's been a lot of people going out and doing a lot of outdoor activities with international travel restrictions and such. So ticks are pretty prevalent, especially in our area. My wife and I have each had a tick bite in the last year, thankfully not with Lyme disease, but some reminders and things you can do if you're out there. And this can also apply on a job site. Mike had given an experience he had at a mining site in Minnesota area, where they had a lot of ticks when they walked through the site. So, obviously one of the first things we always do is check ourselves after we've been outside in the yard or anywhere just for ticks, check and have someone check areas on your body you can't see or use a mirror. And then the other one is where there's a lot, use bug repellent and wear long pants as well, or long pants and long sleeve shirt if your arms are going to be kind of in the bush as well if you're doing a lot of work. So again, in our area, I was reading some stats that I think attendance at state parks is up by 35% because there's really not a whole lot else to do. So just be aware of if there are a lot of ticks in the area. Okay. Oops. So just a brief introduction and background, and we'll try to keep this brief as we go forward. So since I've been involved in the committee in 2012, the goal of the committee is to really, for all of us on the committee from different backgrounds, to help make projects more successful in the industry, which obviously helps our industry, and that's the goal of AIST. So one of the things I did want to do, I was interested in the demographics of who we have on this webinar. So Shannon's going to launch a little survey to see, and on our committee, we typically have one of four persons from demographics, either from OEM equipment suppliers, engineering companies, owners, producers, or construction contractors. So just interested to see what we have for demographics on this webinar. So Shannon, if you want to launch that. If that's
I did, Neil. I
okay.
guess
Okay. Maybe because I'm a presenter, I don't see it. So that's, oh, I see it up here. It has popped up on the other screens. Okay. Thank you. Oops. Okay. All right. Moving forward. So just a couple of general comments on projects in the iron and steel industry, especially in North America. So a lot of the projects here tend to be in our steel industry, especially on the downstream, I'll say downstream blast furnace and downside, maybe coke ovens even, or fairly OEM intensive. In other words, okay, there's a piece of capital equipment that needs to be installed, so there's an equipment supplier that specializes in that piece of equipment typically, so they'll be engaged early on, and then the second half of the project or other major portions, obviously the balance of plant. So whatever the OEM is not providing, then there's utility stuff, there's all the installation engineering, so on and so forth. So in other industries, for example, maybe infrastructure, mining, there really isn't any big OEM. It's just everything is designed by the engineering firm, by the design company. So it's a little bit different, that we're heavily dependent in a lot of cases, not all projects, but quite a few, on OEM supply of equipment. And the last comment I'll make on the introduction is this presentation is really geared to owners, EPCM capital projects, or maybe not EPCM, but just capital projects, not to how a company might set up and manage its own internal project. Like if you're an equipment supplier, this isn't necessarily how you might set up and manage how you're procuring a piece of equipment for a project. This is more how large capital projects are set up. So why develop any sort of baseline budget and scope? So obviously we need to quantify objectives and success criteria of the project. Typically they're laid out in a project charter, which says what your project wants to do, but you've got to get those quantified somehow in terms of a budget and a plan. to understand the project plan and strategy, which we'll talk a bit more about in a subsequent slide on project drivers. Obviously, to determine the appropriation budget of the project, which is a critical aspect of how much money is going to be spent, to manage and control the project once it's been appropriated. In a couple of general comments, we're going to go through some typical kind of phase gate approach stages in this presentation, but there is a varying degree of owner tolerance for maybe risk and execution strategy in our industry. There are some owners that want to basically say, hey, I want to get product to market as fast as possible. So really, as long as the cost isn't ridiculous, I'm going to go ahead and we're just going to do this. So we're going to do less front end work. I want to order equipment, prep the site, do as much as possible early. So that's one strategy. And then there's owners that want to know, very, very close to the budget, how they're going to end up and schedule. So they want to know exactly how the project's going to go before they approve the project or they appropriate it. And the other aspect on that is, depending on the project scope, if it's a project that's been done numerous times and it's kind of a rinse and repeat, then obviously the amount of development work is likely going to be less unless there's some sort of special site requirements or a change in technology. Whereas if you're installing, let's say, a new technology in an existing brownfield site, which means an existing operating plant, it's going to need a lot of development work, and there's likely a lot of risk in doing that, because what you don't want to do is shut down the existing operation while you're doing it, or you want to minimize the shutdown in that. So typical phase gates, I won't dwell too long on this because a lot of companies have various names or acronyms or numbers even for these stages. I've seen a whole bunch of different things out there for different companies. I'd say everyone I've seen has some degree of stage gate approaches. The exact kind of amount of work that's done in each stage can vary, but in general, you've got a conceptual study where you're looking at where are you going to build something and how are you going to do it, and perhaps you release some funding for early engineering and permitting, and then typically following that you'll do some sort of pre-feasibility study where you look at, okay, let's firm up the technology selection, firm up our long lead equipment requirements, potentially do some additional engineering, start working on some early work site prep packages, getting them ready to go. So that in the next stage, when you go to feasibility, you can order long lead equipment and do some site prep. And then in the feasibility stage, this is essentially where you're doing all of your final budget development and setting up your project execution plan in this phase. And then the implementation phase is essentially where you're going to take that plan and you're going to control and manage it as you're going forward. And we'll get into more details on that later on. So this graph is actually pretty dated from the CII, but it makes a good point, and it's still very valid. There's still a lot of projects being executed and developed out there that if there's minimal front end work done, the outcomes are still kind of as you see them on here. So what this is showing is if you do minimal front end loading work, your range of final cost estimate is going to be pretty large. In this range we're looking up to maybe 35% plus or minus 35%, and your average is typically going to be over the budget. As you start doing development work, obviously, you start getting cost estimates in, you start working, you start estimating construction and equipment, so on. You start getting closer to achieving your budget. The difference between the last two, the good pre-planning and the full pre-planning, really is the range. You can see the average is essentially showing, okay, on average, you're going to hit under budget, but the ranges are out there that show, there's still some projects there that are going to overrun in the pre-planning phase, in the good pre-planning versus the full pre-planning. It's very minimal. Again, the point of this graph is to show that effective control is best achieved at the beginning of the project. So what you want to do in terms of getting the project going is doing as much design and firming up as much of the scope as you can do early on, because your ability to influence the project as you move through the project declines. So if you want to make a change, say when you're in construction and you've already installed, let's just say you've installed a valve stand somewhere, and then someone comes along and says, well, that can't go there because it interferes with something. Now you've got the cost to tear that out, re-engineer where it's going to go in a new location, reinstall it in a new location. If you would, early on in the design phase, if you had reviewed that and found the proper location of that, the impact of that change is almost nothing at that point. It might be changing something on a drawing. So, the idea is try to, and same thing goes for scope, try to get as much of the scope and plan sorted out in the early development phases, and that's where you have the best chance of success. This table essentially shows the same thing. Your ability to influence goes down as your spending is going up. And from recent experience or general experience, I've seen, some projects where early stakeholder involvement's been excellent. We've had folks involved from various levels of the plant on projects, looking at maintenance, even early in the equipment bidding phase, so that they're buying in and they're knowing what they're getting. And in that case, results in very few changes later on. And I've seen the opposite, where equipment's being installed and then someone comes out there and says, hey, why is this going here? I want it moved. Or in the final review of drawings before they're issued for construction, someone wants something changed. Well, then there's a lot of engineering work that's got to go into making that change. So early stakeholder involvement is critical. In terms of engineering and estimate accuracy, I won't get into too much detail on this, but this essentially shows that as you're going into an appropriation level at the end of, let's say, a FEL 3, you should be in the range of 40% of the engineering complete that point in order to achieve, say, a plus or minus or plus 15%, minus 10% estimate in that range. And one thing to consider, again, with a lot of OEM-based projects that we do, you'll want to have a minimum the OEM basic engineering in hand, if not some of the detailed engineering in hand on the long lead equipment when you go into appropriation, because changes in the OEM equipment are going to impact the wraparound engineering significantly later on. And lastly, we'll talk a little bit about the famous project strategy triangle. So essentially what this shows is that you've got any one of these drivers on a project, if it's time, cost, or scope, is going to impact the others inversely. So if you've got a time-driven project, you want to rush and get something to market, you're going to potentially sacrifice on costs because you're going to spend more time on overtime. You're going to do things faster, maybe not as much upfront work, so you have some rework in the field later on. And on the scope side, you may miss some, maybe not some major items, but you might miss some efficiencies or nice to have because you're just rushing to get something to market. And same thing goes for a cost-driven project. As you're cost-driven, you're going to do things in an optimal manner from a scheduling side, and same thing, you're going to try to minimize any excess scope that's really not required. So and how this relates back to setting up your project plan and your baseline budget is, if the project strategy, for example, is cost driven at appropriation, so everything is focused on minimizing the cost, and then you move into the implementation phase and somehow someone wants the project to become time driven, then there's going to be an impact on cost. So understanding the project drivers and getting those and the project execution strategy and getting those agreed to by all the stakeholders prior to the appropriation is extremely critical. Otherwise, you're just opening things up for problems and overruns later on. With that, I'm going to turn it over to Nick Olds to go through the next few slides. I think it's...
These are mine, Neil.
Oh, I'm sorry, Mike. I'm sorry, Mike.
No
Mike
problem.
Barry.
Off to a great start. Okay, so Neil's kind of gone through the, the why do we try to establish these baselines and early stakeholder involvement and early project drivers. These slides kind of focus on then how do we get there through the critical functional roles on a project, and those being engineering, procurement, construction, commissioning, and controls. So the next slides will kind of summarize each of those areas. So on our path to baseline, your engineering development kind of follows these major items: scope, definition, and control. So you're starting with an evaluation of the project site and understanding what the project drivers are, what the project goals are, what are our solutions by looking at the site, and generating an equipment list and facilities description that becomes more robust as you work your way through the phase gates. So as you do that and you start to understand the project, you have to set up your engineering with an engineering plan, which includes engineering work packages. So you want to divide up the engineering work logically to a manageable level where your engineering partner is given a scope and a schedule and a budget to produce deliverables for these different areas, however you've broken it down. And then your layout, obviously, development coordination has to follow the same path from the FEL 1 on level where, in the beginning, you're getting kind of familiarity with the site, you're getting major equipment arrangements, utility chases, kind of the big space takers. And you validate that layout or your model with site investigations, or like in the last few years, laser scans have really gone up. So, you do your laser scan, you pull that into your model, and then you have, you have the mill in your model to look through. And then on the design engineering side, obviously the most critical thing is landing on the technology. What is the technological answer that gets you to the, the goal of the project, looking back again at a project charter where the key drivers have been established. And you pick that technology and then you take the process development from there. Everything that has to feed that new line or whatever it may be, you work that through. So at the end of the day, to feel comfortable with your engineering development, you need to have a number of baseline deliverables, which I'll identify, and all of that supported by material takeoffs. You want to know the quantities, the major quantities of commodity type items that are going to be on the job. And as that influences your construction costs considerably. So as I just noted the examples of critical baseline deliverables kind of by discipline here. So in the civil structural world, by the time you're ready to call your baseline, you want to have geotechnical reports done, any major earthwork requirements determined, and then foundation concepts, both concrete and then any structural steel designs, preliminary. Foundations and earthworks are big costs on a project, and so without a geotech report that tells you if you're going to have to drive piles or if you can go with spread footers, any of those other buzzwords that I'm saying as not a civil engineer, but you want to understand what those are prior to saying I know what it's going to cost to set this piece of equipment. And then mechanical and piping. The biggest thing is getting a GA with the major equipment laid out, and then taking and obviously that means an equipment list to accompany that, and then taking all the process requirements and getting your set of P&IDs established. And Neil mentioned before about stakeholder engagement. P&IDs are critical to be reviewed and blessed by the project team. Because they are the foundation for the physical design. And so if if we're late in the game and the P&ID needs to change and we have new lines and new instruments and new valves, you're looking at a considerable, cost impact. So the logical progression through a block diagram, just I need air from here, it has to go there, to a process flow diagram, to a detailed P&ID. You should have all those advanced for detailed design by the time you're ready to cut your baseline. And then obviously piping specs, making sure your material has been established. And then the electrical and systems and process control world, you need a load study done. You need to know how and where you're getting power. And then following that, you build out your single line diagrams to explain the distribution. And then your preliminary physical world layouts. Where's the tray going? Where's the cable and conduit schedule? And an IO list, of course.
Okay, so now
and I'll
Nick's
hand it
gonna
over to Nick here for the next one.
Yeah, so the key aspects for the procurement baseline, there's a number of items that drive into everything. All these aspects of the project all interrelate in some way. But for the procurement baseline, you want to identify, what are the sourcing requirements? How many packages is the owner going to supply all the bulks, the piping, the steel, cable, or what will be sourced in contract packages. You want to identify your main contracting strategies. Is it going to be one main GC, or again, break it down into individual trade packages? How will things be bid out, competitively or sole sourced? For equipment specifications, how much detail are you going to develop in the specifications, or more or less, have performance specs and high level guidelines to allow the vendors to, go throughout the best solution and evaluate those at those points. It's critical to identify the bidders and pre-qualify those that are qualified to supply the equipment and construction packages, as well as the logistics strategy. To kind of keep track of the plan, we often developed a procurement schedule and status report, that identifies each package, target milestone dates for the engineering to develop that package, the vendor engineering to be completed, manufacturing durations and deliveries. And, this can be as a good, simple document to determine, if things are slipping or delaying, which could impact construction or other, related engineering activities. Another key aspect is the materials management plan. This will identify, the basis for bulk material pricing. How will the equipment be delivered, unloaded, organized? Where it will be stored, and how will you be able to find it whenever the time comes for the construction sequence? There often can be significant costs associated with this that can be overlooked when it comes to needing additional warehouse space or dedicated separate crews for unloading. And, there's the time spent trying to locate and find one valve that's been moved, 20 times since it was on site, and end up just buying a new one because you can't find it. The final part too is that should be identified as a plan for contracts management. How will the contracts be set up via, lump sum contracts, reimbursable? Who will be responsible for reviewing and confirming progress and invoices? Who's authorized to address change orders? So all these aspects, it should be identified in the plan, and resources allocated to follow through with that plan. The next area is construction. So, excuse me. The construction obviously plays a critical part in both the cost and the planning for a complete project execution. The construction sequence, means, methods, and definition on the level of control plays a large part in developing this construction baseline and that constructability plan. One key item is to identify what early works activities are required, and do these need to take place, prior to appropriation to achieve, accelerated schedule, or, just the sequence of activities in construction. Constructability reviews throughout engineering is critical to ensure that the design is capable of being built at a minimized cost, and again, how to sequence items. Major items that drive a large number of projects in our industry is the outage work. So are we limited to an outage, on a blast furnace that's scheduled 3 years out? Everything's got to be planned for that window to be worked in conjunction with operations and production. And then other items to address that, affect project baselines and costs is just the site establishment. What needs to be included for logistics and laydown, site facilities for trailers and offices, even remote projects if there's a remote camp for workers, and how workers are going to what shift pattern and that sort of items. And an item often overlooked too is temporary power and utilities that are needed during construction. Obviously the electrical grid's not going to be the first thing to be installed, but sometimes you need power early, and what's the plan for how that's going to be addressed to allow management of the construction. And we usually develop, again, what we call construction work packages. They're similar to EWPs, but are more focused on the actual physical work. So CWPs, they're smaller, more identifiable packages that can be defined independently with clear boundaries. They're typically organized by commodities, area, and type of work. A robust project plan will, have a basis for each CWP, that establishes the scope, budget, and schedule for, that work, which allows for much better tracking and forecasting as you move through a project. If you just have one package for, say, all piping installation without broken down, it's hard to forecast if, you're running over on, say, the water piping or what have you, because it's all just one big number. The key is to break it down into packages that can be organized and controlled independently. And then using the CWPs, these really can be independent of contract packages. So they, you developed based off of the actual work, not so much of what contract it's going to be grouped in, to allow changes in plan and schedule to be adjusted, just based off of how things end up being contracted. The next aspect in baselining is commissioning and startup. So, oftentimes it's difficult to really have a final point plan in place for commissioning when a project's going to appropriation. But some key items are always good to identify and have a basis established as you move into the plan. We often look at it as more than just commissioning, and we call it OCR, operational readiness, commissioning, and ramp up. And a robust plan. The objective is to minimize the time period from when the equipment is handed over from construction to when it's you're up in operations and are realizing the benefits of the project. So in this baseline, you should identify the training requirements and budget, what spares will be needed for startup, commissioning, as well as long-term capital spares, the level of testing that will be completed in shops for both mechanical tests and automation, and a plan for how the equipment will be tested and accepted at site. The roles and responsibilities should be identified, between the OEM, contractor, engineer, the owner project team, and owner's operation team. And finally, there should be a plan to develop the new operational safety and lockout procedures and identify who will be completing these early in the project. That simplifies everything, at the end of the day when you're trying to put together your safe work procedures. Back to Mike on controls.
Mute. Okay, so for project controls, then this is kind of the look back at all the functions we just talked about and how are we managing them and controlling them in project execution. So when you're going through your setup phases and you're establishing all these different outline plans, your procurement plan, your engineering plan, your construction plan, your project controls team needs to be setting up kind of the glue that links all of these elements together. So in the setup, it's coming up with a unified project coding structure and work breakdown structure. And what's critical with coding is you know, on a larger project, you're going to have a lot of stakeholders from, and I guess most considerably, you're going to have an owner, you're going to have an engineering partner, and you're going to have an OEM. Now, each of those companies is going to have their own coding structure for their facility or for their equipment or for just their typical procedures within their offices and their companies. So it's important to establish early on, hey, we're all going to call this area the plant, this area the plant, and we're all agreeing that our tag numbers are going to be in this string of characters and they're going to mean these things. And in the instance where you know, you're not all conforming to one setup plan, and you need to at a minimum have a key that shows you the link between the two. So if I have on my mechanical equipment list, if I have a pump and I've tagged it with my typical pump tagging mechanism that includes saying what type of equipment it is and where it's located in the plant, then I get the vendor pump and he says, this is what I call this pump with this tag number. I have that in my sheet, in my equipment list. And then if my client says, okay, all pumps in this area of the mill must be identified like this, we have all three of those outlined that we can go and map our way through there. And then we agree on how that is shown on our project documents and drawings. Because it seems like a small point, but as projects grow, if the identification of a particular piece of equipment has had a inconsistent naming convention, you will lose yourself and your mind. On the work breakdown structure side, then it's the same thing where, you know, how are we coding every element of the project activity? Are you developing, and there's a slide following this that kind of explains how you would break up a facility. And again, it depends. Is this a brand new site where we're going to establish a work breakdown that will also work for the long-term management of the site? Or are we working into an existing one, or are we setting up an independent project work breakdown structure? So the project controls team has to look at the deliverables from all parties. They have to look at the schedule. They have to look at the arrangements and the facility and help develop this structure. In planning and scheduling, on one of Neil's prior slides, he noted the level of estimate and schedule that you pursue prior to baseline. So in the beginning, you're going to have, you know, what's the OEM delivery schedule? What is the key come to market schedule for the client? And what is the you know, long-term procurement implications and engineering requirements? And as you work your way through the baseline and you come up with EWPs, all your procurement packages, CWPs, your commissioning and handover activities, once you have a well-defined understanding of what all that's going to look like in execution, then you can feel comfortable that your project plan is in place. And estimating is the same way. So you're going to build your estimate with the increasing levels of detail. And at the end of the day, the inputs for that estimate has to be that you have a detailed WBS. So every element of the project has been, carries with it a cost, and the work packages are at the appropriate control level. So a CWP for piping, you know, we know that it's this much pipe and it's happening during an outage and it's going to take 5 men to put it in. So you lay all that out, and then that CWP carries with itself, you know, its cost. Detailed MTOs, a resource plan, any fallout of the risk analyses to help you evaluate your contingencies, and then early vendor inquiries. So if you're actually getting budgetary pricing, or if you've purchased anything in advance of your overall appropriation, you put all that stuff together into your project estimate, and that becomes your control budget. So I talked about the WBS. So on this slide, what it kind of shows is how would you build out the level of detail of your WBS as you go through these different gates. So, you know, at the top level, you have the plant area. You then break that down to facility levels within that plant area. So if you have, you know, an overall integrated steel site, you may have your hot end and you may have your finishing end, whatever that breakdown you may want to be. And then you break it into sub-facilities. So do you have a utilities cellar where just that's all your hydraulics, it's all your compressed air, it's all your grease and lube, everything is in a certain area. Then you break that down by system. Okay, I have hydraulics now, and then that subsystem is this particular hydraulic power unit. So depending on the complexity of your project, you need to take your work breakdown to that level of detail so that you don't miss, and you're removing just allowances from the buckets of money and the buckets of engineering scope that have to be identified. And I have a small example of that later on in the presentation. Okay, and then the last slide regarding project controls is then cost management. So in your baselining stage, you want to have an agreed upon cost report format. To what level are we going to report cost, and to what level are we going to control cost? Do we care if, you know, we've added 2 yards of concrete to you know, a large slab? Not necessarily, but if it's becoming a trend that slab in the design phase keeps growing, then we do want to know that that's a change. So typically, the CWP level and the EWP level are where we manage or what we control to. So if I look at an overall CWP and it's looking like it's going to run high, then I need to see what is causing that. Did my material quantities go up? Did that work shift from being general construction to needing to be done during an outage? What is causing this change to that activity that I previously thought I had identified correctly? And then performance measurement. So all the major services providers on the job, you're going to have an engineering, you will have some version of an engineering and procurement construction management you know, participant. You're going to have an OEM, you're going to have a general contractor. And from the owner standpoint and from the health of the project standpoint, what are the indices that you are expecting out of each of these outfits that are going to guarantee that they're making progress correctly? So we have things like earned value. There's performance indexes against, you know, hours allocated. There's performance indexes for schedule, for cost. So in your study phases, your front-end loading phases, what you want to do is by the end, when you have a project plan that's established, you can talk to your providers and say, I need to see monthly this earned value or whatever it may be. And then finally, there's change management. So you want to have a trend and change register, you know, just a sheet that basically says, originally the project scope said this, but now because of either a client request or a design change or just a miss, whatever it may be, you start to highlight where your diversions from the baseline budget. So on the path to the baseline, you should end up with a nice trend register that's set up that has nothing on it. And then as I'm sure a lot of us have experienced, on day one of the project, you immediately start dumping things in there because everything starts to change right away. But you keep a management of that so that you can look at a trend and say, hey, this is a design change, and you can bring it up to the project management team and say, do we want to chase this? Is it needed? Or do we want to squash it and just say, we're not entertaining this shift in whatever may be. And we'll talk about trend management here a bit further on in the presentation. But you want to be prepared and have a mechanism for tracking and managing those trends as you proceed towards your baseline.
All right, the final aspects for the development of your baseline and your appropriation request, it's how you account for risk. So there are numerous aspects of risk that should be reviewed with all the key stakeholders, as the risk tolerance and mitigation plans are often the key driver for development of the contingency that will be included in the project budget. The project risks are often organized in a risk register, with a scoring and ranking system, and the high level risks will identify as a mitigation strategy for that risk as well. Other risks that play in the contingency analysis, it's taking a look at the level of definition, for that, cost code account or that CWP, are the pricing that is the basis for that baseline, or are they, firm bids, or are they more or less back of the napkin, sketches and concepts? What's the key driver for the project? Cost or schedule driven? Neil touched on this quite a bit, but if it's you're pushing schedule at all costs, there should be some allowances in there for additional premium time and a bucket of money to be able to make up some of that schedule slippages that often happen. Review the project. Are there new technologies and processes that are being implemented for the first time? It's time to sit with the stakeholders and discuss the realities, and if you want to address some extra contingency because of the newness or the uniqueness of the project, this is the time to do it. We recommend taking into account all those risks and completing a range and estimate or Monte Carlo simulation. It's critical to include all the key stakeholders while you're doing this process. The output of the Monte Carlo simulation, that can be used to really develop your contingency amount to achieve a certain probability of success, which I'll show you a little example of that, on the next slide. Now, obviously, it's impossible and not practical to account for every risk in the project. The risk mitigation plan should identify what is being captured in the project and what's not, and agreed upon by the stakeholders. The projects we're all working on now, how many of them identified a global pandemic, in the risk register, and with a mitigation plan and contingency allocated for that? These items outside of the project control, should be identified and really are excluded from the project baselines and budgets. And if they occur, it should trigger a change order. So this slide here is more or less the results of a Monte Carlo analysis. So it's kind of blurry, but that in the near the center there, you have that base estimate. So that's your stripped down estimate without contingency. You run the simulation based on your range estimate review, and depending on the risk tolerance of the company, that's how you can develop your contingency. Based off the 10,000 simulations, if you want the probability of over or under on the project to be 50-50, you need that X number of dollars in there for contingency. And moving on here, since we're kind of getting tight on time, the last thing we want to talk about before the case study is just how we're managing scope and changes in implementation. So the key project stakeholders and the key contributors to the project, we recommend developing a steering committee, and those people on the steering committee should be well aware of the baselines and how the project was, the execution plan was established, and what is in and not in the project. This steering committee should be responsible for the review and acceptance and or cancellation or declining of trends. As Mike mentioned, the trend and change registers, it's critical to identify and keep track of all the changes the project progresses. And again, as Mike mentioned, regular cost control meetings where you review the forecast, the contingency analysis, how much have you spent, in that bucket, those are key items. The last thing I wanted to touch on is just, what is a trend versus a change? So, the project baseline and the contingency in the project, it's meant to address normal events, within the project control. These are often referred to as trends. Contingency is not meant to cover changes to projects. If it's a change or a PCN, it should be approved as such, and the baseline and target for the project should be revised. Trends, that should be covered in contingency often include known unknowns, estimating accuracy, minor errors and omissions, normal market conditions, design development, and specific events, identified in your risk register and response plan. And, items that should trigger a change, it's, events outside the project's control, stuff specifically excluded from the baselines and scope, unknown unknowns, project event risks or major failures of technology or mishaps, and, changes to key project assumptions. If you appropriated the job without a soils report and assumed everything to be earth-bearing foundations, and then you get the soils report and, pilings required, that is a major change. And obviously any changes to the approved baselines for, contracting schedule and scope is all should reflect in the change. Another key aspect, it's important to set up a clear procedure for how change management will be conducted, including the approval authorities for changes and who can sign off on the changes and how those changes will be communicated to the entire project team. This next picture here is just an explanation kind of differences between your changes and trends. So you have your original, budget baseline, and, your approved changes change that budget baseline. But, the trends don't change the baseline, but change your forecast. So in summary, changes adjust the baseline and target, where trends affect the forecast. And since we're running near on time, I'll kind of skip over some more trend and change register details. I think we kind of touched on this quite a bit, and we'll let Mike go into his case study here for a few minutes to help try to pull this all together.
Yeah, so this was just an example from a project to kind of highlight what had gone, basically what has transpired in the actual project environment that meets kind of some of the points that we talked about. So for this particular case, there was a hydraulic piping scope of work. In the front end loading phases, while we were baselining, we had an approved budget established, and that budget was established based on the OEM's pipe specification, their system schematics, and then their functional description for how it operates. That was handed to the engineering partner, who then was responsible for doing the physical design and routing. So take that schematic and now lay it out inside the existing operating mill, develop an interconnecting piping and valve spec that may or may not align with the OEM pipe spec just based on, countries of origin and other things and availability, and then phasing requirements. So, in the beginning, we had an agreed upon approach to when each stick of pipe was going to be built, and our budget was based on that. So we hand that information to the estimating team and the constructability team, who is the engineering partner, the contractor, and the owner. Where the contractor was providing their means and methods for how are they going to build this based on the outage schedule and line sizes and everything. The material cost basis, so in this case it was 304L stainless, and that was to be sourced by the contractor. So we talked about procurement before. You can have pieces of equipment and commodities that the project buys off specs, or you can just push that to your contractor and say, hey, you guys get this. That was the case here. And then there's allowances. What contingencies has been worked into the estimate and schedule based on the unknowns. So that's where we were at the baseline. So then when we go into execution, changes happen. And this became from, project goals shifting, funding shifting, stakeholder involvement that came a little bit later, where the actual system designed by the OEM now had to be adjusted. So they have a new schematic that was made to meet the new routing and phasing requirements, as well as some of the technical requirements that were added from the stakeholders. Then the layout drawings, of course, have to be revised. So there's new routing, there's quantity changes. The interconnecting piping and valve spec changed. It went from the 304L stainless to A106 carbon. So, you have a significant change in material spec. The schedule has now changed. There was a new outage schedule. And then the constructability and cost by the engineer, contractor, and owner. You have another look at the means and methods. You have another look at the cost basis, and your allowances at this point should be reduced because you've taken your engineering a further step. Even though there's a bunch of changes, you've taken your engineering further. Now, ideally, just this process of going through these changes is a cost impact of the job, let alone what the physical changes are. So now you have time spent by the engineer, by the owner, by the contractor, just evaluating what's going to happen here. And then you actually have whatever the cost and schedule impact may be of doing this work in a new way. So jump to the next slide there, Neil. So, trends and changes are going to happen. And this slide is basically there to exemplify, if you build out a robust WBS, you take it as far as you can when you're going to baseline, you can find the elements that are affected by a change in scope. So I've highlighted here just 2 lines out of the, there's 68 item numbers within this particular area. But I've highlighted 2 lines just to kind of show you what information, we would carry in our WBS. So the first thing is the work breakdown structure. So I know by code that any item that is tagged to this area code 22311 is the new finishing mill HPU, because it's mill support systems was the plant area, utilities was the facility, hydraulics was the sub facility, finishing mill hydraulics was the system, and the subsystem was this particular hydraulic system. So that gives me the code for that. And then the engineering work packages. So I had a single engineering work package for all hydraulic piping in the finishing mill, and it's identified there for EWP 250 22310-001. So piping is 250. It was 22310 instead of 11 because it's all finishing mill hydraulics, not just this one. So my engineering work, my time spent, my deliverables are all tied to that engineering package. There's no procurement package shown here because in this case, the strategy was to have the contractor provide the pipe. However, that may change and we may need to add a procurement package where the project goes out and buys the bulks directly, in which case that would get a procurement package number. And then you see the 2 CWPs here that are, one is for installing this particular run from the HPU to the basement. And then another one is a fill line from the bulk storage tank to the HPU. So I have these 2 CWPs that carry with them when are they going to be built, and general construction and an outage. And behind all that is how much pipe did they have in there and has that changed? and then we button up all those CWPs into a particular contract package that then we issue to a contractor. So these are all the activities that we're given this guy to go do. So in here, you can see that there was a baseline construction budget. These are just made up numbers for this particular CWP, $635,000. On the line below it, there's no money, and that's because that was a miss. So in the execution phase, we have to say, hey, we missed this line. Do we need it? If the answer is yes, we need it, it's approved. I now have a budget for it, and I'm working to that new budget. That's my new, you know, my new goal line is to then complete all of this work, including this extra item. But when I compare back to the original budget, I'm having a $0 value there. So it's just, it's a way that I can see all along, how am I comparing back to the beginning? Do I have 0 budget items in the beginning that I have now, or do I have items that were in the project in the beginning that are now zeros? So this kind of ties together the coding, the WBS, the packaging, and the stakeholder engagement and how it affects your deliverables all up front. And if you get too late in the game, like Neil had mentioned, if we were building this right now, and then we realized the fill line piping had to be done, you know, the inertia of the project is harder to push. So it's more difficult to cost effectively into a high quality of engineering, make that change when you're in the field, because there's a million other things going on. So you want to push to have engineering resolution and the correct P&IDs, all of that stuff early, so that you don't have to revisit it too late in the game.
Okay, thanks, Mike. So I'll do a brief conclusion.
You're welcome, Neil.
Thanks. We're a couple of minutes over here, so but that's good. I mean, I think we've pretty much covered everything. So again, I'll just emphasize a few points here. You know, the level of risk a project is willing to accept when appropriating the funds will dictate, you know, the degree of front-end development work that's done. And again, consider the project drivers as factors. If it's a time-driven project and it's got to go, something's got to get done, or maybe it's an environmental-driven project, something has to happen and the cost isn't so much of an issue, then you know, job can get appropriated with less, call it less development work, but there should be more contingency applied through again, some sort of quantitative risk analysis. A defined project execution strategy is required. Again, is it a cost, schedule, scope-driven job? A WBS and budget, no matter, again, the level of detail may vary, but it should be set up to track and manage the costs. A key item is the project stakeholders, and it was mentioned, I think, with Nick and the steering committee, need to be aware and acknowledge the level of development of the project, and also understand the risks involved and how the level of contingency was applied. So, for example, the key stakeholders, maybe sponsors, don't understand that there's certain areas that weren't developed as much because there was a drive to get something done quickly. And then later on, they're coming back and asking, why is this going over budget, or why is this taking longer? So they need to understand the level of development and the risks involved. And then in the implementation phase, a change management system needs to be, or I guess, developed in the development phases, but then implemented in the implementation phase to track any changes. And again, we've all said it, that the best, you know, the best chance for success in meeting the budget is to minimize the changes, major changes that the project could control during the implementation phase. So all those changes in that phase are just going to add cost, or they're going to extend the schedule out. And with that, Shannon, I think we wrap things up.
All right, can anybody hear me this time? Couple things.
Yes.
First, I'd like to mention that we did have a couple questions come in during the presentation. Obviously, I ran a little short on time. We'll make sure that those questions get to the presenters and see if we can't get those answered for you. I'd also like to thank Shannon for jumping in for me at the outset of the webinar as I struggled through some technical audio difficulties. Thanks for everybody in attendance for your participation. And thanks for the presenters, Neil Tannyan, Mike Berry, Nick Oles from Hatch. We appreciate your time and everything you put into making this webinar a success. Thanks to Shannon Kiley and her team at AIST, who worked diligently toward sharing of ideas such as this that we did today. So thanks to all, and thanks for being here. Shannon, you have any follow-up?
Just see the 3 upcoming webinars next week. If you want to join another one, we'll be happy to have you. Okay, thanks so much.
Thank you.
Thanks.
So, bye.
Thanks.
Bye now.